Hello.
Hello. Hello. Hello. Hello.
Hello.
Yes.
People
Hello.
from online. Are you there?
Yes.
Online people, are you there?
Yes, we are here.
Yes. There were some problems you had in the morning.
Yes.
I'm not come solve with those to deal with those who are physically here. It's now your time to see where you are, how challenged you are. You have the challenge that you get to help you to solve them and then proceed with others.
Okay, sawa. Let me share my screen.
Yes, you can share your screen and see. Can you please remove your labels?
My labels, okay.
Okay. Well, you can let it like this. The labels of the junction was the one who was stressing.
Okay. I don't hear you.
I was telling you to remove the labels of junction. So then, what the challenge that are you facing?
First challenge, I have many reservoir. I don't know how to interpret. Yes, I have many things.
You can.
I have one here.
Remove those labels for the junctions.
The junction. Okay.
So try to open the attribute table of tanks, the reflex table of tanks.
Of tanks. Mm-hmm.
So you have a.
I have.
You have how many?
10.
10.
15. Yeah.
15. You guys, you have how many?
13 tanks.
13 tanks.
15 tanks.
13 things.
13. They
Yes.
are the same that you have.
Yes.
And the reservoir?
The
reservoir you have how many?
Was 4 reservoirs.
Yeah, 4 reservoirs.
Yes. They are the same that we have.
Yes.
Okay.
Hey.
Okay.
So then we saw how to add flow control valves. Yes?
Yes, I saw it, and I've already done for one tank. Here I am putting one control valve. Here.
Listen, can you good. What the flow you put there?
1.8. And one correct. 1.8.
1.8. Good. What else? Where else you put the flow control valve?
Not yet another. Not yet. Only this one.
Only that one. And you was thinking that you have many tanks.
Hey. Also, I have a problem. Is it my layout? Is it okay? Or I have maybe some errors? If you look it, is it okay?
No, it's not okay. That way is not okay.
Not okay. Why is the problem?
So then you go to pipes. Properties
Okay.
that the pipes there. Where you put labels. No. Double click on pipes.
On pipe. Yeah.
Yes. Then you reduce the size of. You see where there is GIS.
GIS. Yes.
You double click at that place. You put CAD.
I put.
It's okay now.
Okay. Oh. Okay. Yes.
Reduce the size of the tank also to be able to see.
Bado, you want me to do what?
Reduce the size of the tank.
The size of tank. How?
Yes. How?
Yeah. Oh.
Yes, that way. Good. No, there you remove them. Double click on them, yes?
Yes.
Make them also CAD, not GIS. I don't know what you did.
Okay.
Then there you can increase the size or reduce the size.
Okay.
Yes. So are you facing the challenge, please? That network is the same as we have.
Okay.
And I'm very happy that you already sketched all the pipes line.
Yes, I've already.
Yes. You're doing a good job there.
Thank you. Now, let me size the pipe and then we'll go to size the pump. I think it will be, I will have a challenge. How there is no need to put a pump.
Yes, let me have your colleague also.
Okay. Thank you, sir.
Hello? We have another one online.
Okay.
Yes, sure.
Yes, you are there?
Yes, I'm here.
Can you please let us know where you are now?
For me, I think as I told you on yesterday,
yes,
I failed to reach the place where can I connect the junction in order to build up the pipes. But I think for my fellow here, I see she was achieved to do so. So I think may I share my screen, but don't think how you can help me to arrive where that guy reached.
You can just let me see where you are now. Maybe we'll find a way of helping you. Let's see.
So for me, hello.
Yes.
Yes, for me, I was stacking for day 2. I faced the challenge to move forwards due to the reason that the junction I have, I failed to connect them with the pipes. but once I tried to connect with the pipes, I failed it. So, but even if stop. Wait, stop. Let me share again.
Are you sharing?
Hello, Mr. Gashur.
Yes, we are getting you.
Yes, for me, I think I'm very far, but there is some recording I missed from you, especially during of connecting these joints from joint one to another.
To joint one to another. Then you just go to pipes. You go to pipes. Can delete that lateral. Delete that, yes. Go to pipes. Zoom in.
Let me do this. Pipes.
Let me see. Wait. Go to pipes again.
Okay, to pipes.
Where there is pipes, not on the icons. Just yes. No. Yes. Click there.
No. After here.
There, yes.
Lateral.
You see there is two. There is pipes and there is lateral. Use pipes, yes. Use pipes. Thank you.
Yes, after.
Then
After here.
You have to sketch. You have to sketch from the reservoir.
Yes.
One by one. Reservoir, the next junction, the next junction, the next junction. Gently.
Up to the end junction. All the junctions should be sketched.
Yes, all the junctions should be sketched.
Okay. After there.
If you sketch one, the first one, you zoom to see. Go to the next junction, yes.
So here there's a tank. So even here I can sketch up, then I can proceed with another junction, or I can jump it to another.
No, you can proceed on the tank and then.
So this should be repeated for all junctions.
All junctions. It was a task of yesterday. Just to be familiar on how to sketch.
Okay, so this is
on.
Sorry, Mr. Gashur.
Yes.
So this will be sketched without considering the longest chain, or how?
No, that doesn't happen in WaterGEMS. The only way of doing the easy way, we will see it with in the next session. Can be you just be focused. We will see how at least we know how to do it directly. But for yesterday, we just wanted you to know how to sketch, to deal with those pipelines, to deal with nose, to deal with tanks, or to have knowledge of that.
Okay, but there is the way of connecting direct without jumping from one into another.
In WaterCAD, no.
No.
Yes.
But there is another way of linking. Maybe you have a point with the layout from the Google's. You can track it to the WaterCAD.
That one we will see it. Yes.
we will see it. So
Yes.
once we see it, this will be not applicable for here. We can
No,
we can
you
we
will
can track.
continue using that way because most of the time it doesn't go the way you want. So every time you will still need to sketch some pipes. To there is many you will need in one way or another.
Okay. But also these points here, I see there is they are in different depths, different distance.
Yes, they are
This
different in that.
yes, this cannot bring some errors during learning the hydraulic.
No,
Because
you know those points are coming directly from the field. Directly from the field.
yes,
And on
I
the
know
field,
that. I know once you are at the field, you can take the points at different distance, but once you are coming to start designing, you can put them at equal distance in order to reduce some errors happening during learning the hydraulic model. So how about this?
You know,
Yes.
when you are coming from the site,
Yes.
the points that you have that you took, if you took it professionally,
yes,
are the one which have the exact accuracy than the one that you are trying to edit in your office or to manipulate in your office. So I encourage you first to do your site correctly when you went to site, because you take points according to how you are getting site. Yes.
Mr. Gashuri, I know what you are talking, but as you know, many institutions or many offices, they don't have maybe RTK. I mean the who instrument for surveying. Most of us we are using maybe GPS, maybe locus map there. So some of those instruments have tagged errors, means in issue of workplace. But I don't think if we are preparing raw data, I don't think if it is bad for this data to put it in equal point, because we can go in GIS, we can put those data in equal points, then we can track, we can drag it to WaterCAD, then we can proceed with the design, or we get errors after doing that.
Those one will be in arrangements that you can do. As you said, all our institution doesn't have proper equipment to do survey.
Yes.
So
yes.
From there, you can do some arrangement. For example, by taking coordinates in Google Earth, by taking
yes.
coordinates using GIS, by taking coordinates from them. But most of the time, the accuracy of your data are poor. So when you are taking data like this, immediately someone who is professional will know that those data are coming from the site. So if they are coming from the site, it means they are not giving the real scenarios of the site. If they are not giving the real scenarios of your site, to mean your designs also are not reflecting the real situation of the site. To mean the best way to do is just to use, when you are doing survey, is just to use the proper instrument for doing survey. If you don't have that instrument, you will now start thinking of a way of arrangement. That's where you start taking data from Google Earth. Those data will not reflect the reality of the real world. I mean, your design also will be poor. You get? And
yes, I get.
The instrument also, there are some who gives great accuracy. There are others who are medium, and there are others who are very poor, like phones. When you are taking coordinate using your phone, I'm sure your data are not good. And the medium I say is the one that you are using GPS. When you are using GPS, at least your accuracy are at almost to be true. because on Monday we saw in the introduction of water distribution system, we saw that the GPS almost they have an accuracy of 3 meters, 5 meters, things like those. But nowadays they are using DGPS. So DGPS, at least he has the accuracy of 10 millimeter. To mean when you are positioning a tank and you are putting at a certain location, by returning
Yes.
at your office, you will get the coordinate of exact location, the same exact location. So by taking the coordinate you took next year, you give it to another one, you will go into the site to check where you position your tank. It will fall exactly at the same location. To mean there is instrument of doing survey. Let's try to get those instruments. So then the
Okay.
data from those instruments are the one that we are trying now to interpret and to use in our designs.
Okay, I understood.
Yes. So then what I'm going to do, I'm seeing you are sketching and you are good. What I'm going to do, I'm going to ask one of our friends here who already sketched the pipes to share with you all.
Yes.
Who are online. Those who are here are going to continue to use their systems. So to share with you the updated one, and then we will start from there. Yes?
Yes, it will be better than.
So, any other problems from people online?
Thank you for me. But sorry. As my colleagues here, they asked about the several tanks and several reservoirs at the same network distributions. So how we are,
Yes.
or we need to remove those we are not in use, or we rated them at the network distribution as the data provided from you.
So this network we are designing, it's have like 13 kilometers. And while
Yes.
designing a network long like that one, it's not good to put only one reservoir. So for us, we tried to make other reservoirs so that
Why
it
it
will
is
help
not,
us. Sorry?
Mr. Gashuru? Why it is not? It depends with your area and your demands. If you have
Yes.
if you have a large tanks, can accommodate that kilometers. And if you have a source that can accommodate all the demands.
You know,
So,
have you know the importance of tanks
the importance of tanks?
in the networks? Yes.
Yes, I know.
And can you state like 5?
One of them. First of all, to cater the demands.
Yes.
Yes. Secondly, to store water for to be used in the time when the water,
Yes.
or maybe there's the electricity outage.
Yes.
But also, sorry.
So you see, when I see you had the many importance of the tanks. So what if you have the advantages? What will be the great network when you have only one tanks, and when you have only at least 5 tanks in the networks? Because
If you
it
have,
will also help us to manage the fluctuation when you, for example, people are fetching water,
Yes.
and you know there is a peak hours demand in our networks, and during that peak hours demand, people are fetching much water as they are being produced. So during that time, our tanks will help us immediately to store the water which will be needed at the time of peak hour demand. So it's important for us to have at least more tanks so that we will be able to manage that situation. In other things, when you have several tanks as we are having in that network, during maintenance also, there is where you can find a pipe which is cutted. So you can cross that pipe during maintenance, but the downstream of the pipe, the tank, will continue having water. So based on the locations of those tanks, you will be able, even there are some client which will not realize that there was a breakage of water supply, because they already have a tank which can give them water at least 5 hours or 3 hours, the time that can take you to repair a certain linkage.
Sorry, Mr. Gashuri.
Yes.
I agree with you, but the issue here, may I ask you, those raw tanks will it be get water from the pumping station or from the gravity system?
Sorry.
All those tanks will be
Mm.
subjected to the network distribution. Those things, if it's the network distribution or at a certain places, will them get water from the main sources through the pumping, or will it be get from the high elevated tank that at a certain elevated point, and
As you are
the rest tanks will be at the downstream?
as you are
Because
seeing
now
our
once we are doing a design, we need to see also economic issues. If once we position 4 tanks with all the tanks need to be to be operated through the pumping station, how about the economic issue concerning the electricity power?
So I don't know if you already passed through the network that you are designing, but up to now we didn't get where we can put a pump. Our network is having like 4 reservoirs. Those reservoirs,
Yes.
because you
Yes.
didn't attend the first classes, but those
Yes.
reservoirs are being taken like sources. So to me,
Okay.
those reservoirs can be a treatment plant. They can be the boreholes. We are taking those reservoirs as sources, only sources. You have to know that those are only sources. Yes.
Okay.
So from those sources, we are trying to distribute from here to there. There are some. We are getting to see that there are some main reservoirs. We will get them, like those who are near the sources, and the others are distribution reservoirs. We will see.
Okay, understood.
Yes. And while designing, when you get that there is a needs of a pump, because yesterday we all saw how to design a pump. Yes. So when you saw that there is a need to put a pump in that area, is where now you have to design a pump, you position to the same location, and then you go.
Okay.
Yeah.
Okay, you can proceed. Now you can proceed, Mr. Gashu.
Can proceed?
Yes.
Yes, it's possible. Can you stop sharing, please?
Okay.
So I'm sharing with you the model that you are going to use on your WhatsApp number. You just download it, you open it, and we will continue at the same level with others. Yes, please.
Okay, fine.
Nileta na watoto watatu sasa hivi. Naanza kuongea. Sorry, share your screen.
I'm just telling you that I'm sharing with you the model that you are going to use.
Okay.
Have you got the model in your computer?
Yes.
So you get them, okay. Then what I'm asking you to do is just to set the flow control valve of your networks. There are some who are set it, but I want you to set the flow control valve. We already saw yesterday how to do it. You set the flow control valve quickly. We are going to have a short break, and at 11 we are returning to proceed with other things. Yes.
Sorry.
Okay.
Hello, Mr. Gashul. Hello.
Yes, please.
So the file you sent to us, once we extract it, we see the practice exercise and the practical exercise. So what kind of files we needed to use?
They are what?
You send the file to us, but once we extract, we have a lot of files inside.
I have a lot of files inside.
Yes, once we extract it, and some files are fainted. Only 2 files it seems not fainted, like practical exercise WTG and the practical exercise.
I'm sharing my screen, please.
You need me to share the screen.
Yeah, are you seeing my screen? You see it? Are you seeing my screen? So when extracted,
yes. Okay.
I just send you this one. Yes.
Okay.
Yes, please.
Yes.
So then by extracting them, you will get these files.
Yes.
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 So the one, before I told you that when you do save a WaterCAD, a WaterGEMS, it creates many files. Most of the time they create 4 files. By continue working them, it continue to create some backups. Okay? Then those files have to go every time together. You get? Are you there? Are you there, please?
Yes.
So
For me,
the one you have the one you have to open is this one.
Okay.
Do you have it?
Yes.
Good. The guy on the was not there, yes.
Never mind.
Yes. It's almost the time.
Huh?
It's almost the time.
It's almost the time. So don't take it till today. Don't have breakfast.
Yes. Coming.
That's the way it is, isn't it? You, when you understand the concept of when you start like this, the water is going here, it's easy. Immediately, this pipe is missing. Then we get enough water at this junction, some water. Yes, but without affecting the rest. This is the first thing this so you measure the velocity of the flow. You can try to use it. Bomba naweka bomba kubadilika.
So let's continue. We're all here. Hello, people from online. You're going to continue.
Hello.
Yes, can you continue?
You may continue, but we face a problem for us.
Which problem?
First, some of line has flow 0.45, and then we fail to put the flow water valve down. Let me share my screen. You can see where we get your problem.
Yes. Share the screen.
Okay.
Yes, please.
I'm gonna share my screen. You see this
Yes,
point?
Yes, I see that point.
0.45. We don't know where it comes. And even to
Yes.
remove it, we fail.
There is 2 pipes there.
Oh. Okay.
You guys, you didn't realize that. There is 2 pipes here. You did it one.
Okay.
That is half of the.
Yes, that is the half of the. Okay, then you run the model. Oh,
I'll do. Let me undo.
okay, run the model then.
Okay.
Now it's okay. To me, there was 2 pipes. It was connecting
Okay.
those two
Uh-huh.
nodes. And you had to delete one.
Another problem. Another
Yes.
problem. Another problem to set the flow control valve in this area. We fail.
Yes.
We just used. Here is the what? Is a reservoir. And here
Yes,
is a
that is
reservoir. We can't beside the floor. Here is a reservoir. And we got a challenge to put the
Okay,
floor.
there I explained it. I explained before because there now we don't have the capacity of the source.
Mm-hmm.
The one which should be there, it is the capacity of each source. But as we are doing exercises on a table, we are just imagining that the capacity of the source is equal to the demand, the downstream demand. So we are taking the outlet of that tank, and we divide it by 2. The half at the inlet 1 and the other half at the inlet 2.
Oh.
Yes, but in real world, you have to calculate the water which is coming from the reservoir 1 and the water which is coming from the reservoir 2, and then you put there.
Okay.
Yes.
Now we got and can continue. Now, okay, for example, let's do, for example, here, this pipe, let's see what this tank. And here we come this side. We meet it in another tank.
Yes.
This is the flow, this is 0.9. I count this in, down is in number 1, 0.9. We come
Yes.
0.9.
Yes.
0.9, and then we come another, this one.
No, you can
0.9.
just take you can just measure the flow which is passing through the outlet pipe, just directly to directly to the tank there, the tank up there. Let me share my screen.
Okay.
So you are getting here.
Yes.
So you see that we have 2 outlets, this one and this one. Yes.
Yes.
So then you can see the flow which is passing from this one and the flow which is passing from this one. So then this one, the flow is here. At this one, there is a flow control valve which is not set down here. Yes, this one is not set. So let's set this before. Okay, let's set this before. I have here 5.4.
Okay.
5.4. 0.9. 0.9. It's 6.3. Yes.
Yes.
I just put a flow control valve here. Which is
6.3.
6.3. Yes.
Yes.
And then I run. You have to run. After putting a flow control valve, you have to run.
Okay.
Then my pipe here is now having 6.3, yes?
Yes.
And add
0.2.
also 0.9. So it will be 7.2, yes?
7.2, yes.
7.2, then I will divide it by 2. This one and this one, I get 3.6.
3.6, yes.
So I put 3.6 here.
Okay.
Just put another 3.6 here.
Yes. Okay.
.6.
Yes.
And another 3.6 here. So then I run.
Okay.
You see now here I have 3.6 and here I have 3.6. That's good, eh?
Yes. Yes.
Is it good?
Yes.
So we can continue then.
But I have another question.
You have another question?
Yes. In the notification, when they say the pressure below the lowest physical possible pressure in the system at 1 or it means what?
It means there is some negative pressures in your network. It means there is some junction who have negative pressure. You have to check on them. When they are giving you this notification, you have to check on them. You open a flex table for junction, yes.
Okay.
And then you check those who have negative pressure. You can sort it by ascending, yes.
Okay.
And you get them.
Sawa.
So this means, wait.
Okay.
This means water are not passing in those areas. You see, those are the areas who have negative pressure. To mean water is not passing into those areas in a correct manner. Those areas are having problems. Most of the times, those are elevation problems, or it may be caused by the small pipes upstream there. Yes. So then you have, when you are sizing, when you are doing hydraulic design, you have to find a way of solving those issues. Yes. That's what you are going to see.
Okay. Sawa.
Okay, I'm continuing.
Okay. Sawa.
So let's continue. So the guys, I think you are just proceeding in sizing. Yes. I see you are busy. I don't know what is happening in your computer, but I want you to I don't know what I'm thinking that you are doing sizing, but what I want you to show you now, we took data from Excel, yes? Some can start by sketching as we are doing. Others can start sketching by starting using AutoCAD, yes? Yesterday we saw, yes? You can take those pipes from AutoCAD and you put it there. It will be possible. Yes. So others may say, let me use those points from GIS. May get the points from GIS and import them into ArcMap. Yes, to see what will be happening. So what we are going to do, I think you only have this issue of negative pressure. Yes, this issue is caused because our pipes are not sized. There are some good guys who have tried to size, and they are just up to here. Yes, they are up to here. The other part here is good. Yes, to mean by sizing, you will end up by removing all of those negative pressures, and your network is now sized. So we will try it in the afternoon, but I want to show you other tricks. Yes. So for example, me, after doing this survey, I found that there is some point that have a long elevations, for example. So you remember one of our guys online told us we had ways to use Google Earth. We just take points, just take coordinate, and we start sizing. But after that, you get to the site, you find that you got wrong elevations. Yes, elevation in water supply is the important things. Yes, so there is a way of taking those elevation and import them directly in this model that you are using. Yes, so there is a tool called Trex. This one, yes.
Mr. Gashu,
Yes.
what that tool is for?
Is helping you to take some properties of shapefile or some properties of DXF, those who will use AutoCAD, and take those properties and put directly into a node that you want. You get? So it's a matter of clicking on it. You go, you find the tools. I want you to use the shapefile. So you select that one, the shapefile that you want. And after, when you select that one, they will give you, for example, I can take my junctions. Yes. They will immediately show me the titles of my attribute table. So maybe I will need to put the elevations. Those elevations will be in meter. Yes. I state a buffer zone. A buffer zone is the area which will be approximately to the areas that I have. Yes. And then the georeferencing, most of the time they are using the same. I will also, the buffer zone, you see, for example, you may be having, because we are using the shapefiles for the same thing, it's like approximations. You may be having a node here, and the one we are going to use in your shapefiles is not falling exactly there. It is, for example, 2 meters apart. You just specify like a buffer zone, but you don't put it bigger, because if you put it bigger, it will fall to the other one. Yes, you just see the approximations.
50% is it?
50% is okay.
Okay, sorry again, for the elevation, is it X, Y, or Z unit?
Z unit.
So we have to change there to from 50.
Yeah, from Z here, yeah, to meter, yes. So, you know the reason that I don't want to proceed here quickly, it's because you may also need to do not change everything you have in your model, yes? So then, you may require, for example, to use a selection set. So, there are some of us who have realized that they are somewhere where water cannot reach. Maybe our surveyors have took wrong coordinate. For example, here. So get this tank. This tank is located at this elevation. Yes? You get them all? So that then the taps here is on this elevation. Is it possible to take water from that tank to this one? So myself, Bashur, I say my surveyor have do something wrong to me. I have to go to check on the site and check the properties of this one. I went there, I get the properties, I found that the elevation is long. So then I will need to update this one. And they may be, for example, 100 nodes that I need to do that, yes? So what I have to do is just to make a selection set of those nodes, yes? For example, I can take this one. Let's have also, we are here, just try to imagine, yes? Let's try, for example, also this line. So I just make a selection set of nodes, of those nodes, yes? I just do a selection set of those nodes. I call it update, not to be updated. Yes, and those not to be updated immediately. The selection set, it is created. Then, can you have a pen? Write for me this one. Then you can write me this one also. You can just write node 1. We know that this is taken like 1, this is taken like 2. Maybe we'll take 3 only. The other one is this one.
The same level.
Are they in the same level? Yes, they are at the same level. So this one also, same level. Changed. Okay, let's take those 3. So then we come again to tracks. So we select, you can use shapefile, you can use DXF. Unfortunately, you cannot use Excel because Excel doesn't have those georeferencing things. So then you make, to mean the data that you are coming from at the site, whether you put it into shapefile or whether you put it into AutoCAD to have a DXF. Yes. So here I'm choosing my nodes. I will be sharing with you those shapefile for you to redesign again. So then I specify the elevation, yes, the unity of my X and Y, the unity of Z. Your referencing is not there. I'm allowing also to update those inactive element. Then instead of selecting all, I will just select my selection set I did, yes, not to be updated, yes, and then I do OK. So immediately, those nodes have been updated. Yes?
Yeah.
Yes, those ones have been updated. So then you are going to see in our
By changing the
elevation.
Yes.
So now we are seeing if this one is still the same or it have been still the same. Oh, maybe in the shapefile I didn't change. I didn't change in the shapefile. It should be. It should have to be changed. The others, I changed them. No, this doesn't change.
Maybe it has changed the elevation for the tank.
No, you have to change the elevation of those nodes. Okay, let me. Where did I change? Okay, let's see this part. I know this one have been changed. This one. Okay. So let's check the elevation of here. It is this one. Yes. Write it. The elevation of here. This one. The elevation of this one was this one also. Wait. Is the same elevation that you have? This one. You can check for me. Is this the same for your model?
The first one.
The first one, yes, the first one. This one.
12. No, it's not the same.
It's not the same.
Right, it's 12.
I'm using
1248.6.
48. I'm using the model that I already changed the derivation to explore those shape files. That's why I'm getting confused. Okay, just for doing practices. Here you have how much? 40? 48, yes? I know this line all I have divided by 40. This also 48, yes?
That one is
49.
48 also. 48. 49.
Okay.
Second from us is 49.
So,
49.
so then let's try the tool. Let's try the tool. So by coming here, the same scenario, I do shapefile. Just take junctions, take elevation, fit, then let's take all, because I didn't make now you get it's updates. Yes? See, it's updates.
Can you put the first one?
The first one, you remember I put 40.
Okay, 0.6.
Yes.
It was from 0.21.
Yes, you know why it wasn't changed before? That's the model that I used to edit the elevation. So to me, it wasn't the first one. If I would have the old version, it will be changed. But for you, I'm going to share with you the shapefiles, and then you update yours to see if those elevations are being updated. Yes, the same scenarios. Okay.
So in that way, after you finish that one, automatically, if you compute, the direction will change.
If the direction was wrong, it will change when you compute. Yes. So then,
the site, the scenario that's going to be also changed.
on the
On the site,
yes.
will be changed.
No, I said that you are coming from you send someone from the site. When he brings data, you get that maybe there are some data which have took long, which it took bad, or you have been using a Google Earth by creating those routes. And reaching on the site, you get that the routes you take on Google Earth is different than the one which should be on site. Then you want to update. You don't have to come and sketch again. You just have to update the one you have from Google Earth, and it gets the properties from the one you get on the site. You get? Yes. Yes.
Let's say I have gone to site.
Yes.
And I took this data.
Yes.
And I have specified to put my DP, the domestic point,
Yes.
there.
At that point.
And I have already taken the data, coordinates and elevation. If I change them in this software, don't you see that if they have
I'm using a Google Earth. So I just take a point. Yes? Let me see. Okay. I just take a point on a Google Earth. Yes? I just position this point to be here. Yes? Then after going on site, you know this point is giving me X, Y, and Z. I don't know where exactly it is. Instead, you go, you see this is a church. And my friend have positioned a water point just at the right corner of the church. Is that used? For us, you have X, Y, and Z. You go, you check where your X and Y are falling. Yes? And most of the time, there is some cases that we got when you put your X and Y in the GPS or in GPS, immediately your point is falling in the church, and you start asking yourself what happened. Yes, and the other time it falls in the areas of the house or in the house, and you start asking yourself what happened. That's the issue of not getting the precisions. Yes, please.
What is the case? Usually, this will happen once you have started the design
before
they find the points at the building.
Yes, this will happen most of the time because you remember we had before the steps of designing a project. We had the preliminaries, we had the feasibility, and we have also a detailed designs. In preliminaries is where we saw that you can just start designing your network, for example, on a Google Earth. You take some points, you take some coordinates, everything, you take it by there. But when you are going to start feasibility, yes, you will now start thinking, is the location I took, is X, Y, and Z I took, will fall on the exact location that I take? Yes? And this is where you have to go there with your GPS or with your DGPS or even with a phone. I know it will not match because the X and Y you took on Google Earth will not match with the X and Y on site. Okay? And most of the time, for example, the point that you took between those two houses, most of the time you will find that one point has fallen, for example, here, and then maybe here, or even in the road. It will not match. So then you have to update the things you do on Google Earth with the real things that you are taking from the site. That 3x will now help us. Yes, please.
For the case of updation.
From the case of
updation, I saw there we updated the elevations.
Yes.
But you can find the area almost the elevation
the same is elevation.
Yes. Of course, we face the same scenario. You go there, you find almost around 15 or 20 meters. The elevation is almost the same.
But you say 15 and 20. What about 16 or 100 meters?
Because if I go 100 meters, it means I change the location of that DP.
Of the water point. Yes.
So I'm asking if I change the elevation of that point, or something, maybe I can do it and find the same elevation. What should I do? If I go for updation.
And you get that the elevation is the same.
Yes, the same, because it will find around the location the highest point. I mean
Yes.
the highest of the lowest point.
Mhm.
What should I do? Because I will find where I have located my tank
Mhm.
is lower than
Is lower than the
targeted
targeted area.
Yeah.
So there, you just check if the X and Y also are also correct, and then you move on. Because this tracks, most of the time it is helping us when, for example, there is even a time, there is some, it's because for you guys, you didn't put, we had a way of putting those elevation together with building the model. But there is a time we find that the elevation doesn't even went good or went in. So use tracks to import directly those elevations.
No option to elevate the tank.
If you elevate the tank, to mean you are editing your data.
You have to check position of the reservoir.
Yes.
So, sir,
Mm-hmm.
you are going to think there doing verification about
Yes.
you have to create the shape there so that you can change the points where you find there is a mistake.
There is a mistake. Yes, you can create this. You can create the shapefile, or you can create also a DXF. Because the design doesn't end only on WaterCAD. We also do maps. We also do profiles, and you can just take those cards that we are using for Google Earth or for shapefile or for CAD. You just verify if they are still falling in the same place or in the same levels. Yes. Mhm.
I was asking, we see that the short file has its characteristic that it is entirely Y and X.
Yes.
Now I'm asking myself, was there a need to say good selection so that they match?
So the way of using a selection, it's because you may not need to change everything which have been taken. Yes, you just do a selection set of what you want or what you want to verify, and then after you do you do calculations on only those ones. You get? That's the only way of the only reason we are doing selection, because as you saw, I was only dealing with this this pipeline. I just do selection set of this pipeline, and it's the one that I'm verifying if it's true. Yes.
So we do the selection still in the electronic.
We thought, but we check all the network, and if all the network been changed, to correct everything. So then, after tracks, I want to share with you those shapefiles, and then we will try to see how to import now the shapefile we have into the model. Yes? While we'll be having a shapefiles, we try now to see how to import it by using the model. Yes? So up to now, because by doing that, I know most of you are going to ask me many problems. Why do we have a time to sketch those lines? Because with shapefiles, it's easy to import the network. Everything will be imported immediately, even the pipes. But you will have to, I'm going to ask yourself, are there any way of getting those pipes? Up to now, you are designer. Are there any other way that you are finding that we can get those pipes? From DXF, we saw it yesterday. Yes. Other way? Hmm?
So can you get pipes from KML?
KML also, but it's safer. You already drawed those one. It's what you are going now to see.
From KML.
Okay, for KML, you change it into shapefile, and then after shapefile to WaterCAD. So then I'm sharing with you Hello?
Yes, hello?
Yes, I'm hearing you.
Now even as we are hearing you, but almost for 5 to 10 minutes we are not hearing you.
Yes, we will, because here people, I have to circulate checking on them.
Yes.
As I'm taking just time for you also the time to check for you also. Here it's require me to go to everyone's computer to check if we are together.
Okay, fine.
But I'm asking myself, why I'm updating my things and being updated, yours is not updated? Why?
Which one?
Hmm?
Which one?
Okay. So I've been updated you?
No. Tengo paso en el video.
One time, I told her, send me the picture. She said, yeah, your friend would be what? Let him go. Let him go. Yes.
We use this shape phase to shade for updation of our model.
To create a model. Yes.
Not to update. You have to create a new model.
We will create a new model which will be similar than that one, but with those shape files. We'll see how to create. That's what we are going to see now.
So we are creating a new one.
Yes.
So I have to close this one.
We will cross this. Don't save it and cross it.
But I want to do updation for the first model.
From the first model.
Is it possible? Because if I go to select the file.
So we have got a problem. Help us.
What problem do you face? Facing?
Let me share my screen.
Yes. Share your screen, please.
Have you seen this slide?
Yes, that one. Yes.
Yes, I've got a problem. The water supposed to flow in this pipe, which is 3.6, but the one coming at a 4.68.
Sorry.
The water coming from the reservoir, it is at a 4.67 liter per second. But in this side, I'm supposed to see to deliver 3.6.
Yes. So have you set your flow control valve?
Yes, I put here my control valve.
Click on it to see. The flow is 3. Have you run your model?
I have run it. There's some problem. Let me show you. I compute. Have you seen a lot of problem? Tell me.
Let's see that pipe.
You want to see the pipe?
Let's see that pipe.
Okay.
You cross that one. Try. Listen. Listen. Are you getting?
Yes, I got
Check
you.
if that flow control. Check if that flow control valve is attached on the pipe, please.
Okay. It is. It is. Oh.
Try to move it.
Yes. It is attached me.
Okay. Then let me check. Listen. Let me check the elevation of your reservoir. Because there are some elevations of the reservoir that we have changed. That one is
1547.
1547. And the tank is?
Yes.
I think that one will have been changed, yes?
1544.
1544.
Okay. No, to be 14. It is 1544.
Zoom out to see.
It is 15.
This is the reservoir that he's saying about, right? 1546.
15.
So then, are you listening?
Yes, I'm listening, but I don't get you.
You just try to increase your reservoir elevation to 1552.
1552. Okay.
Yes, reservoir. Because the reservoir was a little bit at the same level with the tank, and when the tank is full, the water is coming back from the reservoir, from the tank to the reservoir.
Okay.
Try to run and see.
The problem is still pressure.
Oh, it's all been reduced. Let's see. Now it's okay. It's okay?
It's not okay. The negative, we get negative flow. When you
The negative flow, this is because you just draw the pipe from the tank to the reservoir instead of drawing the pipes from reservoir to the tank. To mean, when you are drawing the pipe, you have to draw from where water is coming to where water is going.
Okay.
Yes. But that negative sign doesn't affect anything.
Okay. Sawa.
Sawa.
Asante, tumeelewa. You have understand.
So then we are having shapefiles that you are going to import them into WaterCAD, WaterGEMS, yes? So to mean your topo surveyor are coming from the site or have queried everything, he wants you to simulate a network, giving you shapefiles, yes? How then to take those shapefiles that he's giving you and import it into WaterGEMS and do simulation, yes? No, there is a folder.
The last one.
Yes, the last one. There is the first one that I shared. That one was not good. You delete it. The shapefile that you have is this one. Yes? You have this one. You all. Yes? Yes? There is a junction shapefiles, there is a pipe shapefiles, and there is tank shapefiles. Yes? You have this folder. Then you are going now to proceed. So the way to do is always to go to model builder. Yes? As usual. Yes? You create a new. After creating a new, then you are going to select S3 shapefiles. Yes? So then here it's different from others because for the AutoCAD we saw that we only choose one file. Yes. From the Excel also we was choosing one Excel for this one and other Excel for this one and other Excel for this one. But now for the shapefile, it allows us to choose all together. Yes, please. You can choose all together. To mean you may have many infrastructures, you have them shapefiles, and then choose all together. Yes. And then from there, you will be able to check on your junctions. Yes. You may be able to check on your pump, your pipes, and you may be even able to check on your tanks. Yes. So then you do next. You select the unity. Don't forget, please, to precise the connectivity, the tolerance of 1 meter. You get? You get? Okay. Here then you are having junction, you are having pipe, you are having tanks. You may also have reservoir that I didn't put. We will see. We will see. Yes. Then here, the same scenario as we did for the Excel. You just select for junction. Just select junction, label. But most of the time, because we are using shapefiles, and shapefiles are having georeferencing system, so the X and Y will be produced immediately, automatically. So for our junction, we want also to add elevation. Yes, the properties of elevation. Yes. Elevation. Yes. So then. So then, I just want you to do this. Let's imagine that you are forgetting to choose this elevation on a junction. Yes? Yes? Let's imagine that we forget to put this property. Yes? So then we will use Trex to import those elevations. Yes? Okay. So then we continue on the pipes.
So if I selected, how do I unselect?
How do you unselect?
Yes.
So it's a matter of returning back. You go to dust one, you come here, and you do none here.
You imagine
Imagine that you forget it. There is also some case that you just have shapefiles, but it doesn't have elevations. So then when you import it, you realize that your shapefiles are not having elevations. So then you ask the topo surveyor or the GIS draftsman to produce elevation for those shapefiles. Produce elevation and then return again with shapefiles. We're not going again to rebuild your model. You may still sketching those pipes, and after when the elevation is coming, now you use the Trex. You import immediately those elevations. Yes? for the pipe, we choose label. This you may rate it like it is. So for the start, you may say that you want it to start, or you may want it to stop. No, the tanks, let's put it, because the elevation of the tanks, it's required to calculate the minimum, the initial, I just want you to see how Trex is working. Yes?
Sorry.
Mm-hmm.
Yeah, for start there is start node and end node. For connectivity, no relationship there.
The connectivity every time is because you saw that we have did the tolerance. So when you sketch, when it will sketch for the model itself, it knows that this pipe will be connected to these nodes. Yes, it will immediately know where to stop and where to start. There is no need to specify that in there.
Also, I'm saying that we are having stop with double P, we have stop with single P.
Stop. There is, because we have many stops. There is stop pressure. You remember, here they are giving you all of those stuff which are included in the attribute table. Yes. I have to help this one.
We don't get you.
Don't see or you don't understand.
We don't see, the screen is stuck, and we don't hear.
Sorry?
The screen is stuck. What you are talking, we can't see. We can't hear you.
So then, for the tank also, I think you already did.
Sorry, sir. Can you repeat on the pipe? Sir. Sorry, sir.
Sorry?
Can you repeat on the pipe? Repeat on the pipe. We don't get you
On the pipe?
Yes.
I just said that you select the pipe, then you choose label, and you rate it like this.
Okay. Sawa. You can continue.
So for the tank, you choose the tank, and then you do label. X and Y will be put automatically. Then you choose for elevation. Elevation, yes. So for the air base, you know that is basically. Initial. Maximum. and then minimum. So always remember to check if the unity are the same. Here, if you are working in meter, to check if the unity is meter. If you are working in feet, every time you have to remember. Yes. Then you can do next. Next again. The result is this one. Yes. If you reach this level, are you there? Can proceed. So what I wanted to show you is that one of the results that they are telling you that 6 missing nodes created at the pipe end node. The question that you were asking, if the pipe is drawn and it's found that there is any nodes at the end of it or at the starting of it, it's immediately create a node. You check, you see? Okay. Our network is now here. Is it the same like the one we have? Not reservoir. That's what you're about to say. Okay, I'm coming. Are it the same?
Yes.
Have you checked it on the elevations? Have you checked on the elevations? Zero elevation. So then I want you just to do the same way that we used in Trex and import those elevations. Yes? They use the same shape file. You take only for the junction. Yes. So let's try it. We do Trex. Then we choose shape files. Yes. I choose the file. Make sure I choose the right one. Then I select elevation. It has to be in feet. In meter. Yes.
Let me see if it's
No, the elevation is in meters. Yes. So, have you tried to see the result? All of those elements. Outside of the location of the, maybe those factors are the reservoir or the tanks. We're going to see. Then, have you checked if it's the elevation went on them? Mine are there. They are there. Yours is not there. The version of reservoir we already put. See there. No, even reservoir.
So the junction is that.
Siwezi kujishtua nikisema
Junction is that is at the junction of the reservoir.
Sorry.
kazi tulianza kupita. Kama sio biashara. Wale na hata walianza kula wanaona matamu. Steam ndio nini? Steam. Nani? Na TikTok. TikTok mna wawili, kuna TikTok nikimfuta. Angalia watatu. Sio walikuwa wanajikopi. Sio itakuwa mbaya. Hata hivi. Kwa TikTok ni mtandao wa kijamii. Kuna TikTok si right, kuna TikTok si nani? Ndio hiyo TikTok moja. Hiyo pesa nzuri. TikTok line au TikTok right? Hiyo line futa. Nitaangalia. Yana kutoka sijui au kitu. Sote kwa sio ya. Ni sababu ni kile moja. Mbona hapa? Kwa hapa kwa. Picha. Para casa. Como se chama esse vídeo? Eu cheguei a gente aqui a mim. Não.
I'm validating mine. Yes. Mine doesn't have a problem.
Oh no, computing.
So by computing, only negative pressure. There are some who have problems. It doesn't. There is some who doesn't equivocate. It's a matter of size and now. Reservoir. So now we are going to see, because we just put nodes, we just put stamp and the pipes was goes immediately. And then we are going to put reservoir. That's good. It's running.
This is a picture.
Those people online, are you there? Hello?
Yes.
Hello?
Hello.
Yes, I'm sharing. Have you please debrief the model using shapefiles?
Yes, let me see.
Can I see your screen, please?
Well, actually, we did it.
Can you share your screen?
Okay, I can share.
So your network is good, right? Have you faced any challenge?
Not yet.
Not yet. So
Yes.
I'm just asking you because we are all looking at it. Can you validate? Validate. Oh, I have many questions. Oh,
I've already done next, sir.
you validate, no problems. But you have many.
But there were a lot of problems when I compute. You see?
Yes. Let me try to see one of the comments you have.
You want me to read you?
But that one is not the one we are working on because that's one have flow control valve. It's not the one that we are breathing right now.
Now we are doing what?
There is a new one that we come to breed together using shapefiles. Oh, he is. I send him personally.
We have used the new one you sent to us.
Sorry? Have you checked on your WhatsApp, please? You want to share with her? Yeah, there is a gentleman who wants your WhatsApp to share with you the model he did.
The WaterGEMS we use, the one you will give us at the morning.
No, listen. On your WhatsApp, I shared with you shape files.
Okay.
You and the other guy.
We have it.
Have you saw it?
Yes,
You have
this
it?
one. Yes, this one.
Let me share again with you.
I have it, sir.
With the small letters, not capital letters.
Are you there on WhatsApp?
Yes.
You get my email, my WhatsApp, my message?
Let me check.
So, guys, let's continue. I'm giving you reservoirs, yes? You are tired. So you get reservoirs? Oh. So those, you get reservoir? You get them? Can you please insert them? Did you get them? How many people you get the reservoirs? The other guy, I'm not seeing him.
We have it. You have seen it.
So others have built a network using those software that I'm giving you. So you are supposed also to build that one, and then you add reservoir after. You get it? Yes, the same interface. So, those who are together with me, can you stop sharing, please? Okay. So those who are together, I'm just trying to import my reservoirs. Yes, the same scenario. I just select the shapefiles. Yes, I browse where my reservoirs is. This one. Yes, I just click on it. I check on them. They are okay. Reservoir 1, reservoir 2, reservoir 4. Yes, they're together. I do okay. Just select meters. So up to here, I have to select my reservoir. Yes, label, XY field and Y field. we go on it automatically. Then after, I select my elevations. Yes. From here, I'm ready to go. One reservoir, 4 reservoir is created. Yes. That's my reservoir at the same place. Yes. Yes, it falls where exactly the nodes are. So what you have to do, because we come to add our reservoir on the same location where those first nodes have been created. Yes. What you have to do, you just select these pipes. You can just, instead of connecting it on, don't want to. Wait. I can increase. I can increase the size of the dots to 2. Then from there, I will be able to select those dots. Yes. I can just connect this pipe. Instead of being connected here, I connect this pipe to the reservoir, then delete this one. Yes. The same here. Connect this pipe to this reservoir, then you delete this one. Yes. There are 4, there are not many. You can remove the point and then connect the.
There is no option to merge.
To merge?
Or to decide.
Is it be possible to merge a tank and the reservoir and the nodes? You invent and see. It's not possible, my friend. But you guys, you like automatic things.
Yeah, we do.
So then, once it's have all your I want to know if you only have a negative pressure, only negative pressures in your network. We are together? So we are together? How to connect the pipe? You just click on it, you right click on it, and then you do reconnect. Click on it, select it, and then right click on it, choose reconnect. So we can have a lunch, and after lunch, we will try to size this network to optimize, size everything. We will see how to make it simple. Yes. Yes. Hello, are you there?
Please, I'm thinking that you are already at this level. Yes? No, we proceed. Because I want to size, listen, I want to size the pipes with you so that you may see how you have to proceed or the way you have to proceed. Yes? I want to size the pipes with the can with you continue together one by one. So what I'm asking you, yes. Okay, guys, I want you to be there and you are going to proceed the section. After finishing this one, we will see how to code. Coding, yes? Yes, please. Yes, coding those pipes, everything. So, I want you just to be focused on this level. Yes? Be focused.
Sir, here you are speaking.
Yes, how are you?
I'm okay. Here you are speaking before
You get the school.
I don't see the screen. Sure you are speaking. Okay, now it's okay. Now I get it.
Okay. Where is the other guy?
I don't know. Hey, it's him. I don't know where it's him.
You get the screen.
Yes, now I get it.
Okay, thank you. You still have the Excel sheet of the pipes that you are using?
Yes.
Can you put it on WhatsApp?
Yeah.
On WhatsApp group, that Excel sheet, that table of pipe size, yes. Pipe size. Want to have them. You put it? The Excel, the pipe, the table of pipe size, DN. Yes, I got it.
new point.
All of this. Okay. Then, by sizing, as I told you, it's better to start from the downstream. You continue upstream, but remember, I not yet put the demand. Yes, let's put the demand. There are some who already put. I wanted to change them, but there are some who already put. Yes. So let's start. Let's make the demand somehow bigger so that our pipes will have a variety of sizing. Yes. Okay. So then let's make our demand to be 1.2, not 0.9 or 1.6. 1.6, yes. Because there are some who want to remember the way I added all the demand together. Yes. Let's have a look on that. But this is done when you have only add the demand of the same value to all the nodes or to the specific node you want. Yes. So before doing that, you just create a selection set. Yes. We create a selection set. I want you to be together.
Yeah.
I will go slowly so that each and every one proceed. So we are creating a selection set of end node. Yes. Some can decide to create it like this. Others can decide it to do quickly by doing query. Yes. By doing query and then dead end junction. So the difference between dead end junction is that they give you only junctions. When you do dead end node, they give also other end with other infrastructures. Yes. Sorry.
Yes.
So then, for us, as we want to put demand on node, we are going to dead end junctions. After here, you can create your set by right-clicking on and then create a set. Yes. Someone yesterday asked me about add to a selection set. This is when the set is already created and we want to add those infrastructures to that set. For example, I'm doing such that I create a set apart. I create a set apart, but with, for example, one junction. I call it dead end junction. Yes. Get together. So then, after that, I can get those end nodes and then add them to the junction that I have created. Yes. So then here, you can just come to selection set, select those one. You see they are there. Yes, please. So then we are going to add demand on those nodes together. Yes, please. May you repeat again? Wow. So then, repeat what? I repeat how to. When? Many junctions. The way to select many junctions. To see, you have to have a query in your mind. What junction that I want to select? Those are those end junctions. Yes. So if I want to select those end junctions, I go to query I want to query, yes. And then there is this one. This query is meaning to select the junction at the endpoint. Yes. I may also select the junction or infrastructures at the end of the networks. Those are dead end nodes. Yes. So you see? Yes. So then we are going to add the demand. Yes. So one way of doing that, you can just select the session, those junction, then select them, you open the attribute table of it. Yes, please.
Yes.
And then you add one by one. One by one.
The demand.
Yes. You click on here. The demand is here. You add one by one until you get all finished.
You said you
Please, slowly. Yes. Those are 12 junctions. Yes. I think you are the one you have. See here, just go to demand collection. Yes, click on it. There is this icon. Just comes. Yes, 1.6. But guys, I was showing you many ways to do that. I'm showing you many ways to do that. Yes. So that one was one of the way. The other way we saw is just to go on a node, just double click on it, you get properties, just demand collection, you open this one, you also add demand. Yes, this most of the time is applicable when you have different demands. Yes, but for us, as we are doing, we are putting all demand, all nodes the same demand. Yes, you can just now go to demand center, demand control center on this one. Yes, at this level you will need to initialize all junctions. You may be in hydrant, you may be in trunk, you may be in search tank, you may be in customer meters, but we are in junction. So you will need to initialize all demand, all element. Yes, to mean here, all our nodes are appeared here. Yes. So then, in order to choose the one we want, you go here on this query, you select dead end node. To mean each and every selection set which have been done, it will be found here. Yes. So then you edit all your demand to 1.6. Yes, please. Then you close. If you go to one of them, you will immediately get to have a demand one. Yes, to have it. Yes, please. So from there, you can then validate your network. Demand control center. I repeat this one. Let me repeat this one. You go to demand control center. Yes. Yes, you want to continue. You do okay. Yes. And then at the first time, those junctions were not here. You need to initialize all demand, all element. Initialize them. Yes. And then after, you get query of those end node dead end dot end junctions. Yes, they comes. If you don't initialize and you select here, they will only comes those who will appear there. You are good? So then our demand now is on network. Yes, please. So after doing that, what is next is to put flow control valve. Before sizing, please, I repeat, put flow control valves. Before sizing, you have to put flow control valves. So our flow control valves always goes just behind the tank. I'm reducing the size of those junction. I see they are disturbing. To make it one. So then I'm starting. So we're going to start from downstream. My downstream I found is this one. Yes, going this way, coming this way, this way, this way, and then up to the end. Yes. Let's start from this one. This one. So the first things to do is to just position our flow control valve. Can position it here. Yes, please. Yes. Is possible, or even gets positioned in the pipeline. Yes, please. I want you to see this. When our flow control valve is like this, it's have the direction of this way. Yes, the direction of this front one is the way our flow control valve is set to look. So as our water is coming from this one, yes, and our flow control valve is going that way, to mean you have to reverse it. You just right click, you just select it, right click on it, and then reverse it this direction. You give it a good direction. Yes. So then we get the flow from this part. It's 2, but I'm not sure if it is 2. We know how to display other digits. We know how or to change units. Just by going to the item you want, right click on it, you can immediately change the unit from there. Yes. And then can display other digits. You see? Yes, please. So here we have 1.6. At the other side we have 1.6 again. And for here it will be 3.2. Yes, please. Yes. 3.2. Yes. Be set on flow control valve. 3.2. Immediately after setting the flow control valve, you have to run. You have to compute. Yes. So you will see the pipes here. The pipes here, it's only rating 3.5. Some are asking why this negative, but we already know that our pipes, instead of drawing like this way, we draw like this way. So the flow is going in opposite direction. That's where my minor sign is coming from. If I want to remove it, I just select the pipe, right click on it, and then reverse the pipes. By running it, see the negative sign is gone. Yes. is gone. So after setting this flow control valve, I go to the next one. Our network is having 30. The next tank on this line is this one. I have to set this one also. So then I also, because you have one inlet and one outlet, I just only have to check the flow of this one. It's 8. Yes. I immediately create a flow control valve at that level. My flow control valve again in a wrong direction. Yes. I have to reverse. You guys, you always have to check on those things. Yes. Because if the control valve is looking on wrong direction, first of all, they will tell you a notification that your flow control valve is not delivering the flow, and another notification telling that there is a reverse flow in your systems. So you have to check that the flow control valve is set to the correct directions. Then you set it at 8 also. 8.
So I have a question.
Yes.
So if you want to reposition
Thank you. If you want to reposition your flow control valve,
maybe it was between
maybe it was here.
yes, and the other junction.
So what you have to do is just to take a junction, you go on it, click on it, and you position it again.
It's turning to a junction
Yes,
with the same elevation.
with the same elevation. The reason why you don't put elevation on control valve is because, for example, you see, if I put a junction here in between this one, it will immediately create an intermediate elevation between this one and this one.
So there's no any problem if you turn that control valve into a junction.
Yes, no problem.
Double click.
Sorry, I can tell the pipes are
All the pipes. We are going to work like this. We let it. It doesn't affect anything. Yes, it doesn't affect anything. Repeat what? You just go to junction, pick it, and then. So then, this control valve have been set yes to 8. Yes or not? Not yet. Hello. You guys, let's be together. To 8, yes. Then we learn our model. Yes? We are still having negative pressure as notification, yes?
Sorry, sir.
So the next tank is which one is this one? Yes, please.
Why did you put 8?
I just calculated.
I think it's 6.4.
Sure?
It's
Here I have 8. You also have 8. Yes. You also have 8. You have how much? You have 8? Downstream. Here there is in 10 branch. I only have one branch. on this tank. You not take the nodes. You take the water out of the tank.
Sir, we don't hear you. Tukusikii.
You're not hearing.
Yes. I'm not hearing you, sir.
Okay. So you were asking, there is 5 junctions. Yes? This one, this one, this one, this one, this one. 5 with 1.6 minus 5 by 5. So how much?
8.
Is that what you have?
Yes.
So then we're here. Yes? So let's continue.
Okay.
So at this level, yes, we are having one also. This one is 1.6. We set a flow control valve here.
Okay.
Yeah. 1.6. Yes?
Yes.
Then, after that, you can learn your model. Immediately, we are having what? We are having another notification, which is telling us that the flow control valve 4 cannot deliver the flow. And the flow control valve 4 have a reverse flow. Yes? So when we are having this one, either water is going to a wrong direction, which that we have here, it's only the same reason. So you have to solve so that the water will continue to go in its correct direction. So the best things to do, first of all, is to size the pipe, the upstream pipe. Yes? Because for example, here we are having the pipe of this one and the velocity of this one. So we try to increase that pipe to see how it will behave. Yes? So then see where is the tank here? So I want us to increase the hood, this hood pipe. Yes? Then I'm not asking you to pick one by one. Yes? I just want to use a query. The query that you are going to use is trace. So then we may trace the shortest path, yes, from where is the other one? See here? Where is that one? Okay, it's from here, yes, to this tank. I think you are all doing that. So they show us this pipeline, yes?
Mm-hmm.
Following that, we open the pipeline. And then we try to increase this pipe, the pipe here. Try to increase it. Probably let's make it 2050, just by random, to allow water to go, yes? And then you learn.
How much?
250. So my flow control valve is now delivering the flow, yes?
Wow.
So then we continue. Yes?
Oh, wow. Sawa.
Hello?
Hello. We are
Are you
together.
following?
Yes, we are following.
Okay, then we continue.
After pressing,
You already trace,
yes.
open reflex table for the pipes, and then you make the pipes 250. Probe edit all together. 250. So then, I think we already set a flow control valve here, yes? There is no other here. Then we come here. Here also you have to set a flow control valve, yes? So as we told before, we don't know yet the flow from this one, from this source, and the flow from water source. So what we have to do is just to imagine that this flow will be divided by 2. So here we have 12.8. So divided by 2, we'll be having 6.4. Yes? 6.4. So then I try to create flow control valve for this one and flow control valve for this one. Check my directions. This one is having a wrong direction. I reverse it. This one, I set it to 6.4. And this one also to 6.4. Yes. And I run. Remember, every time you set a flow control valve, you run your network. Yes. You get again that this flow control valve is not delivering the flow. Yes or not? Yes.
Yes.
So then I have to see the upper. See, the way I solved the first problem will be different than the way I'm going to solve this one. You have to analyze and to have the concept in your mind. So why water is reversing? Yes?
Why is so the difference?
Sorry? Didn't detect. How? Hmm? Sorry?
126 plus 126 is not 3.2, but the answer is 123.
You put also plus.
No,
Mm.
after setting from the control bar.
So then, so here, what I was telling you is that you have to think, and you have to understand why flow is reversing. Yes, the first part, the flow was reversing because the pipe was small to deliver the flow. Yes, but at this level, we are just like blocking that water. Yes, to this location, because water is no longer going in this direction, but it's mostly going to that tank, because there is a tank here. Yes, and if you get the flow here as lies to, like the velocity is less than 4 point something, you have to reduce that flow which is passing to that area. So one way of doing that, we just set the flow control valve to 1.6. Yes, 1.6. You set the flow here to 1.6. Yes, and then I run my model. You see the flow is still coming, but the notification was gone. Yes, so my flow control valve here now is delivering the flow. Yes, so the remaining tank is this one and this one also. Okay, we continue. So here I get 6.4. Just put 6.4. I learn. See, people are looking for me, are looking at me. You already done?
We are listening first.
Yeah, you are listening first.
Yeah, before listening first, then I will.
Okay.
Because by doing the one listening, you're giving the response, so that's why I have to listen. Okay.
But I'm going slowly.
Yeah, you are.
You think so?
I'm not going slowly. Oh, okay. Let me now reduce the speed a little bit. I will pass. No, that one cannot change. That one in yellow cannot change.
So I should be
Even if
change the flow.
Cannot change. The demand, you can change the way you put the demand is the way you can change it. That global is there.
I should change it individually. Mine is true.
So then, the other one, this one is setted. The remaining one is this one. So here we are having 9.6. They are having one. The sum is what?
11.2.
11.2. Okay, 11.2. Yes. Then I learn again. It is okay. And they are remaining those one. Yes. So this one is having 11.2, and this one 1.4, 1.9, I think. 1.6, and it is 12.8. 12.8 divided by 2, 6.4. Ah, good in mathematics. 6.4 at this level and at this level. And this one 6.4. Yes? 6.4. Yes, 6.4. So I learn it again. The remaining one is this one. This one, 6.4 here. Yes, that's why what I have to put.
So how the flow control valve have to be installed before the tank?
Yes. It's better before the tank.
Better before the tank.
The other one is this one. This one is 6.4 or so, right? Six 6.4 divided by 2, 3.2. Yes? And then I learn my model, I compute. Now, as I set my flow control valve,
Flow control valve on transmission.
On
transmission.
Remaining one.
That one.
The one who is remaining. I already set.
From the source.
From here. Okay. Put this also. I think it's 3.2. 3.2. 3.2.
Not that. Is it allowed to put your?
Right?
You are putting flow control valve on the transmission. Is it allowed?
Yes. Every pump, every tank has to have a flow control.
So that source is extracting 1.6 and this one 1.6.
So here we go. So you see that all my tanks, I have already set all my flow control valve on my tanks. Yes? To mean the water which is circulating in my network now are the calculated one. Yes? Now the water which is circulating are calculated one. What is remaining is to size my pipes. Yes? If here, for example, if here I'm having a pipe which is delivering 3.2, is that velocity okay? No. So I have to find a way of putting also my velocities on standards. Yes? This is how to size. And you have to size the pipes at the minimum level to optimize the cost. Yes? Okay. So let me have a tour. I want to see where you are. Hello?
Hello.
Hello, please. Yes, can you share your screen to see?
Yes, I can share.
Let me see.
Have you
Yes,
I'm here? I got a problem. My flow go down instead of going up. Yeah. I introduce my
zoom out a little bit to see. Zoom out, please. Out. Zoom out. Okay. Have you checked if there is no other tank upstream?
My problem is that I come with this flow 12.8. I divide it into by 2.
Yes.
And this pipe is supposed to go 6.4.
Yes.
But this pipe.
Yes.
I have a problem with this pipe where
yes.
Instead of 6.4, it goes 18.7 in the opposite direction.
Yes.
Remind me the way how done at that time.
So, zoom out a little bit. Again. Oh. So you see the brush just right your mouth at the right corner. The branch which is there. Yes, there is a tank at that branch. There is a tank at the end of that one.
Let me find.
At the end
of
that branch, of that connection, of that one, yes, at the end of that one.
Okay, it is here.
You set the flow of that one.
Okay.
The problem is that you will not be
okay.
That is.
How is that flow which was reversing?
Let me look. It is okay now. It's okay.
Okay.
I can continue.
Could be not here. Some applies to
Mr. Gashu,
Yes, let's
can
continue.
you please show us
how she reversed the direction.
How he reversed the direction?
Yes.
They ready?
Huh?
They ready?
How is
How?
how she reversed the how she managed to reverse the direction.
Ah, for him, he set the flow control valve of this part. For this area, set it this one. And because it's like he was blocking water. Instead of water going this way easily, he went directly to this location. There was a tank here where he doesn't set the flow of this tank. So more flow was coming here instead of continuing this way. So by setting this one, now the water is continued this way. It's like there is a lower elevation in this area than this one. So water pretend to go here in most of the quantity instead of here. Yes.
for tank number one
For this.
from the reservoir? For tank number one.
Yeah. This one we are going to change it to 1552. 1552. You guys, you do you check on this one? This reservoir, we have to change the elevation of it to 1662. 1552. And there is also another reservoir that I want you to change. Not a reservoir, a node.
Number three.
Number 3.
That one, that the node, there is this one. At this level, I just want you to make this junction because the junction it seems to be higher than the tank. Yes. So I want to make it lower. Yes.
How much?
15, 20. No, 15, 15. Yes. So then we are going to start to size. Yes. Yes, please.
The 03 was saying how much?
15, 15. So this, I'm seeing you guys taking notes. Yeah. You should take notes of the tools, the whatever, but this is an exercise that we are doing. You will be facing other elevations and flow control valve settings with your home, with your task at your jobs. Yes. So we are going to size. It's better again to start from downstream. You can start from those two pipes. Yes, we are together. Are we together?
Yes.
So I can start sizing for these pipes. Yes. The only way to do, you can just select it like this one, like I'm selecting it, and then open the flex table of it to the one I selected. So from here, I'm seeing that my velocity is this one. Yes. My pipe is this one. Let me try. Let me.
Joe. That's what Joe.
Okay, let's continue. I'm trying to edit this one. I put the smallest pipe. Put which one? Do I have to put which one? This one? 34.9. Let's see if it will work. 34.9. Then I learn to see. My velocity is now high. Yes, there's no way. I increase it again. Oh, 43.5, and it will be. Let me give you a hint. Yes, the best velocity to go with 0.7 and 0.9. That one is the best. The best velocity. So when you finalize all the model, you start now optimizing. Divide, minimize the pipe where it's possible to be minimized. Yes, and increase where it's possible to be increased. But at this first trial, try to put your elevation between that range because it's an average one. Yes. So then let's go. That's a hint. In using WaterGEMS, that's a hint because there is a place that will work on very high velocity at maximum 1.5, and after that start causing problems, and you return again to increase the pipe of downstream. It's better to take the average one, size everything, and then you return. Reduce where it's possible, increase where it's possible. Yes. So let's use that. For example, this one, it's 5.65.6. 65.6. Yes. I learn. Oh, this is too high. I reduce again. 55. Do 55, yes. That will be okay. So I edit the pipe H, DP, DN, DN 63, DN 10. Yes, please. And then I line. So my pipe C is okay. Yes. I continue with other one. I take this one. Yes. So I take also this one. I think it will be the same, 55, yes. I make it 55. It will be the same. Because the flow are, yes. Yes, please. As the flow are the same, I'm putting the same pipes. So then, I'm asking myself, we didn't even change the Hazard William. You guys, have you changed the Hazard William? Can you change it, please? You open the pipes, all the pipes. Then you change the Hazard William. For HDP 140. Okay, learn it again. Is it okay? that okay? So what I was about to show you now, yes, it's just to check on the pressures. So this pipe, you see the velocity is okay, yes? So then now you have to check on pressure, starting pressure and the stopping pressure, this one. Yes, please. Make it the unity, change it to this one. So then what I want you to check, those are meters, yes? Yes, please. So when those digits exceed 100, you immediately know that you have to use PN16. Yes? If you check this, one of this one is exceeding 100, you immediately shift to PN16. If one of these shift to 161, you shift it to PN20 or PN25. You get? This is where you manage the pressure you are going to put on your pipes. Yes? On starting and stopping pressure. You get?
You consider.
Yes, if one of them, to mean if starting one or the stopping one falls into another range, you change the whole pipes. Yes?
This is, I think, dynamic pressure. If you close all other valves to other locations.
You want to run it at full, at a steady state.
Yeah, if it happens that you close some valves in other locations, I think the pressure can increase.
Will increase. There is a way of, yes, there is a way of doing that. You just take that the demand, the whole demand, you multiply by factor of 0. It's immediately for with 0. With 0, yes. It's immediately take the whole demand as there is the whole network, as there is no one is consuming that you run that model. If you run it, it will show you the maximum one.
If I assume that for this pipe, other pipes will be closed, but this will be operating, no change, no raise of pressure.
So this one is size DS. So we continue then from this one to this part. You size by portion. Yes? Portion by portion, yes? So then from here, as it is difficult also for me to select the way I'm selecting, I can use a query. The query will do it quickly. I just select from here to here. Yes, please. Shortest path. Yes. So then I'm going to size also that one. The flow is this one. I have to reduce my pipe, yes. Let's make it 70. This is 70. 78. 78.6. Then I learn. What happened? Okay. You see that this pipe is also sized? Yes? This one is 19. See that here there is some pressures which are even more. Yes? Here I'm having a pressure of 200. I'm having a pressures of. So I have just to sort them to see. You see? I have pressures that are more than PN 16. Yes? Yes or no? You have them.
Yes.
So then there we are going to use which types of pipes? PN 20. For some PN 20 and some for PN 25. Yes? Those one from upper to here is from PN 20. And down there here, PN 25. You guys. He's saying that all PN 20 can manage this one. Why you are working under risk? No. You know the safety factor. It's for the industry who produced the pipe, not for you who are designing it. You get? Imagine if the one who manufactured that pump didn't put that safety factor, and you are thinking yourself, maybe there is a safety factor. 4 meters are not. So.
1.5.
Then I have to check where is my PN 20 and where is my PN 25. Yes? So this place from here up to here, there is PN 20. Yes? I just edit this portion. Yes, please. I'm fearing that you are here or not. See, I only have PN 20 with this one. This one. 110. Yes. PN 20. This one. 83.6. Yes. .6. Yes, and this one will be PN 20. Guys, am I sizing alone or together? Alone. Online people, are you there?
We are together.
At least you. Here they are sleeping.
Shortest path.
Manager, are we together?
Shortest path.
Stress. Someone tell me the PN25. PN25. HDP. PN 110. PN25. Someone can share with me the internal diameter? Yeah, someone have them. Anyone? Anyone is sharing with me? So on WhatsApp, I shared with you an Excel which have PN up to PN25.
Okay.
Sorry?
You sent it today.
You
sent it now.
Yes, now, right now. Have you seen it? Get it or not? So PN25, HDP, this one it's having 76.4. 76.4. Oh, almost this one. 76.4. Yes, PN25. So now, do you find sizing easy or it's very easy? Yes?
So cumbersome. It is very easy, but
Yes.
it's so cumbersome.
Sorry, I'm not getting you.
It is easy, but it is so cumbersome.
Yeah?
So easy, but it takes time. But it is easy, we can do it.
I'm not getting you.
She said it is easy, but it takes time.
It is easy, but it is so cumbersome. It takes a time, but it is easy. We can do it.
It's because it's your first time. When you already use it many times, it's not cumbersome. I'm running Swahili.
Okay. Inachukua muda, but you can do. It takes a time, lakini we can do.
Okay. So then,
The first pipe was PN.
the first pipe was PN 20.
I know, the one with ratio for something.
It was 10.
10.
10, yes. So then, after sizing this one, yes, please. Want to check one of the junction?
Yes.
The junction is causing the problem. Is it only you have it?
Thank you.
Because I will be preparing you a small network, yes, this evening, be preparing you just a small network of like 5 kilometers for you to do from the time that I will drop it in on WhatsApp to the time of getting out of this training, just to see if what we have covered, everything have been captured, yes. And this one will be considered like a final assessment to get a certificate. Yes, please. Yes? There is? No, as you see, you are all memorizing what we already see. It's only a matter to see if you get to your big managers there. They give you a network, at least you know where to start and where to finish. Yes? So then, if you are the manager, now whether you kill your organization or you save it. Then there are some people who asked me about how to code, pressure, and those stuff of coding, yes? So for this final stage, we are going to see after sizing your pipes, yes? After getting all pressures, wherever, you're now going to prepare like a last layout that can be shown on a workspace like this one, yes? We are together. So, you go to symbology. Start with pipes. Let's start with pipe. You right click on it, you do new. They are asking if you want to do color coding or annotation. Let's choose color coding. It will be like this one. Yes? So then, are you going to code based on what? Diameter? Velocity? Let's take the one who is saying velocity. Okay, you go to velocity, you just fill the key field name here. You just click velocity, yes, check it. Our velocity is there, yes, and we want to all element. It's possible to code only some selection sets. Choose only some selection set. You say let this be coded and the others let it as it is. Yes, like you can. It's what we are going to do. I'm saying, maybe you have a big network, you want only a certain part to be coded, and the others to not be coded, or to have different codes. So you create a section set of different parts. Then you code it according to the selection set you are taking. Yes. So then for us, we want them to be selected. Then you come here. You say, for example, from 0 to 100. From those who have velocity less than 0.5. Yes. So to me, those value who is less or equal to 0.5. Yes. But we know that 0.5 is still in the range. We take 4.9. 4.9. Yes. And then we choose the color. We give them which color? Red. The red is the best color for those who are not working. Let's give it, because those velocity will not be in the range. Let's make it red.
But red is also for selection. Red something is not red. So it might be confusing.
Okay, let's make it this one red. Yellow.
But okay, but you can change the background to a bit less white. That way more colors will be seen.
Okay, let's put it this one. So be seen. Then the one which is falling into up to 1.5, it will be colored how?
Yellow.
Yes, because we already have a range up to this one. Those one here will fall into this color, and those who fall from here to here will fall to another color. Which one? Maybe pink?
Put yellow. Yellow.
Put yellow.
Yes.
Yes. Others are lying me. So this one also. This one, the remaining one, can make them the same as this one. Sample that before. Let's give that maximum. Let's make it maximum. This one, this is the minimum one, it's 0, and the maximum one, the range that has been calculated with. The maximum one, let's make it. Is there any velocity which is greater than 10? No, say 10. So then you can apply. By applying, you immediately see that your network is now colored. Yes. Those who are falling into a range of yellow are good. Those who are falling into this one, but this one we have sized. Yes. No, not this one. You get? Yellow is good. And you remember from here, we have. Yes? So let's size this one also. See if by sizing it, it will change immediately. Yes?
Okay.
Let's size it. The flow is the same. Let's make them 55. Yes. This is it. DPE. PN 63. PN 10. And then as it falls through into the range, you see, it's changed immediately. Are good? So it will be for you. It will be okay. It will be for you if you code those ones and start sizing the pipes by seeing if the velocity is falling into a range or not. Yes? This is one way of coding your pipes. You can choose also other way you will exercise. Yes? So for me, when I'm doing coding, I most of the time do coding on junctions. Yes, to show me where is the junction of PN10, where is the place of PN10, where is the place of PN16, where is the place of PN25. So it's helped me to analyze my part categories quickly. Yes, so let's see it also. Can code many. Oh, this is nice. On junction, yes, I go on coding. So I find pressure. Yes, this one for junctions. Then my pressure is ranging from this one to this one. Yes. So my pressure is ranging from this one to this one. I have a node which having this pressure. I will check on that one to see what is happening to it. Let me check it before continuing. See?
Okay.
Those one, I think that they don't have elevations. This one doesn't have elevation. Yes, I'm right. So I can just put the elevation of the upper one to see. And the other one is which one? Other one is this one. So then I code the junction again. So now I have pressure. Pressure is this one. Yes. I create the range. I have those range. Which one is those one? So then I just say that the nodes which have pressure up to 10, up to 100 should be show up with green. Those up 16 will be show up with blue, and those with 220 will be show up with this one. All right, this one. So then the above one will have lead. The above one will have lead. Yes. I then apply. You will see my junction are changing. Yes. All of those one are having. See, they are having different colors. Yes. So this one of the way of coding. You first your coding make all blue without knowing how.